Welcome back, guys. So in our previous videos, we had talked about all the questions from 6.1 up to 6.17, and in all of those questions, whether these are some specific real world problems or not, what we also had some mean value, we had some standard deviation, and in our real world values, what we have done, first of all, we have converted all of these values into the z domain. And what was that? If we had some value that was x minus mu divided by sigma, so equivalent of it was z, and then we had found out all the probabilities by using the z distribution table. Okay, so this was basically the theme in all of our previous questions. Similarly, in question 6.18, what is the statement? The heights of 1000 students are normally distributed with the mean of this and a standard deviation of this. Okay, we are given this mean, standard deviation. Assuming that the heights are recorded to the nearest half centimeter, how many of these students would you expect to have heights less than 160? Means the probability that x is less than 160 centimeters, okay, between this value and this, okay, and equal to 175 centimeters, greater than or equal to 188.0 centimeters. Okay, so this is the first part of this question. What do we have to do? This is the small x, and similarly here, what we will do first, we will convert it into the z, and then after it we will use the z distribution table. It would be very easy because it is already in the formulation, that probability that x is less than 160, and then it would be probability that x is less than z. Similarly, in b, between 171.5 and 182.0 centimeters, so what do we have to do here? It will be the probability that x is less than z2 minus the probability that x is less than z1. Okay, what is z1 and z2? This is, let me call it x1 and let me call it x2, and for each of them, for z1 it will be x1 minus mu divided by sigma, and for z2 it will be z2 x2 minus mu divided by sigma. Okay, similarly here you have to convert it into z greater than or equal to 188.0 centimeters. It is the probability that x is greater or equal to 188.0 centimeters. We cannot find it directly because the z distribution is in the form that x should be less than the value of x. So it would be what? It would be 1 minus the probability that x is less than 188. Okay, so this is what we have to find out. This 188 will be converted to the z, and then by employing the z distribution table we will find out the solution. So this is all about question 6.18. in question 6.19, what is the statement? The statement is, a company pays its employees an average wage of this with the standard deviation of this. Again, we have the mean, standard deviation. If the paid wages are approximately normally distributed and paid to the nearest cent, okay, what are the options here? Part A of this is, what percentage of the worker receive wages between this value and this value, which is just like part B of our question 6.18. The highest 5% of the employees hourly wages is greater than what amount? Okay, so here the probability is given here. What is given? That probability that x is less than or equal to z, and this is also given 0.05, which is 5%. First we have to find out the value of inverse of this 0.05. from it we will get the value of z, and from that value we have to find out the value of x, which is x equal to mu plus sigma into z, which is from the same formula which we had previously discussed. Okay, so this is for part B. In question 6.20, the statement of the question is the weights of a large number of miniature poodles are approximately normally distributed with the mean of 8 kgs and a standard deviation of 0.9 kgs. If measurements are recorded to the nearest tenth of the kilogram, find the fraction of these poodles with weights this over 9.5 kgs means probability that x is greater than 9.5 means this is the 1 minus probability that x is less than 9.5. Why less than? Because we had to convert this one and this one to the z, and in z distribution table we cannot imply it for the values where the value is greater than some specific value. B is of at most 8.6 kilograms. Again we had to convert it to the z and then find it out, and between this and this again the same question as we had here in part A and we had in question 6.18 part B. Okay, in question 6.21 again the tensile strength of a certain metal component is normally distributed with the mean this per square centimeter and the standard deviation of 100 kilograms per square centimeter. Measurements are recorded to the nearest 50 kilograms per square centimeter. So part A is what proportion of these component exceeds this value per square centimeter in tensile. Means this is x is greater than 10,150. So it is what we have to convert it into the z value, and to convert it into z this is the formula, and after converting it we have to use the z distribution table, which is not applicable over this formula because this here x is greater than this. So therefore what we have to do, we have to find the value which is less than 10,150 and subtract it from 1. Here we will get it. In part B, if specifications require that all components have tensile strength between this and this, again the similar one as of this part C, per square centimeter inclusive, what proportion of pieces would we expect to scrape? Okay, so similar one we have to find them out and then we will find the answer of it by employing the z distribution table. Okay, so now question 6.22, which is somehow different than the above questions, and we will try to solve this question in our upcoming video. In these questions try to solve all the questions, but this part B is for you. You have to practice it out and we will also discuss it if you have any question. So that's it for today, in which I have discussed all the questions which were relevant with our previous videos. If you have any question you can ask me in the comment box. See you soon.